guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to look at exam style questions that have to do with modulus functions, the factor theorem and the remainder theorem, and as well division of polynomials. Right, so, but before we start, please make sure that if you're new to my channel, you hit the subscribe button and don't forget to turn on the notification bell so that you don't miss out on any new videos. So let's jump straight into it. Right. So number one, it says solve the inequality, right? Modulus of x plus 3 being greater than or equal to 2 times the modulus of x plus 3. So we're going to do this. We're going to solve that inequality by squaring both sides, such that x plus 3 squared would be greater or equal to 2 squared times x. 2 squared times x minus 3 squared, then x squared plus 6x plus 9 is greater or equal to 4 times x squared minus 6x plus 9, such that x squared plus 6x plus 9 is greater or equal to 4x squared minus 24x plus 36. So if we take what's on the left hand side to the right hand side, we're saying we get 0 being greater or equal to 4x squared minus x squared, we get 3x squared, and minus 24x minus 6x, we get minus 30x, then 36 minus 9, we get plus 27. Yep. So we can rewrite this as 3x squared minus 30x plus 27 is less than or equal to 0. And of course, if you factor out 3, we get x squared minus 10x plus 9 less than or equal to 0. Now, if you factorize here, for us to get a 9, it means we have multiplied minus 9 and 9. So we get x minus 9. Factors that we need, x minus 9, x minus 1, less than or equal to 0. So we want the region of y that is less than 0. Says that if we come up with a quick sketch, right, this is 1 and this is 9, and our graph is like this, then we need the value of f of x that is less than or equal to 0. It is bounded by the region from 1 to 9. So the set of values that we need, 1 less than or equal to x less than or equal to 9. This is the solution that we need for number 1. Now moving on to number 2. Okay, so now for number 2, we want to solve the inequality modulus of x minus 2 less than or equal to 3 times the modulus of x plus 1. So as well, if we were to solve by multiplying both sides, by squaring both sides, we say x minus 2 squared is less than or equal to 3 squared times x plus 1 squared. Then x squared minus 4x plus 4 is less than or equal to 9 times x squared plus 2x plus 1. Then x squared minus 4x plus 4 is less than or equal to 9x squared plus 18x plus 9. So if we take what's on the left hand side to the right hand side, we're saying 9x squared minus x squared, we get 8x squared. Right, so let me rather say 0 is less than or equal to 8x squared. Then 18x plus 4x, we get plus 22x. And then 9 minus 4, we get a plus 5. So if we rewrite this, we're saying 8x squared plus 22x plus 5 is greater or equal to 0. And 40 plus 20 and 2, so we're saying 8x squared plus 20x, let me rather say plus 2x plus 20x plus 5 greater or equal to 0. Now if you factorize here, factor out 2x here, get 4x plus 1, then we factor out 5, get 4x plus 1 greater or equal to 0, such that we've got 4x plus 1 times 2x plus 5 greater or equal to 0. X will be equal to minus 1 over 4 or minus 5 over 2. So now if you come up with the number line here, if you come up with a quick sketch of the region that we want. We want the region of y that is greater or equal to 0. So here we've got minus 5 over 2, then here we've got minus 1 over 4. Right, and then we know our graph will be like this. Right, so we want the region that is greater or equal to 0. So it's this region and this region. The region that is above the x-axis, in other words. So this region is bounded by, this region is given by the set of values for which x is, here x is to be less than, right, x is to be less than or equal to minus 5 over 2, or x is to be greater than or equal to minus 1 over 4. So these are the two solutions that will give us, that will satisfy that inequality. Right, so this was number 2. Now we shall move on to look at number 3. Allow me to erase this part here. Right. So for number 3, we need to divide 2x to the power 4 minus 9x cubed plus 13x squared minus 15x plus 9 by x minus 3. So here we're going to use the long division method, whereby we shall say x minus 3 into 2x to the power 4 minus 9x to the power 3 plus 13x squared minus 15x plus 9. Like this. Then x into x to the power 4, those 2x to the power 4, those 2x to the power 3. And then 2x to the power 3 multiplying the divisor x minus 3, you get 2x to the power 4 minus 6x cubed. And if we subtract, we get minus 3x cubed. Then here we shall drop the 13x squared, such that x into minus 3x to the power 3 will be minus 3x squared. And then minus 3x squared multiplying the divisor x minus 3, you get minus 3x to the power of 3 plus 9x squared. And this will give us a 0. Here we get 4x squared. Then we shall drop the minus 15x, such that x into 4x squared, we get a positive 4x. Then 4x multiplying the divisor, we shall get 4x squared. 4x squared minus 12x. Then here if we subtract, we get minus 3x. Then we drop the positive 9 here. Right, to say x into minus 3x, we get minus 3. Then minus 3 multiplying the divisor, we get minus 3x plus 9. Then if we subtract, we get our remainder 0. So therefore the answer that we need is 2x to the power of 3 minus 3x squared plus 4x minus 3. This is the answer that we get after we carry out the division. Now let's move on to number 4. Allow me to erase this part here. So now moving on to number 4. Number 4 says find the quotient and remainder when x to the power of 3 minus 3x squared plus 6x plus 1 is divided by x minus 2. So as well, if we carry out the long division method, we are saying x minus 2, we are dividing it into x to the power of 3 minus 3x squared plus 6x plus 1, such that x into x to the power of 3 is x squared. Then x squared multiplying the divisor, we say we get x to the power of 3 minus 2x squared. And subtracting here, we get x squared. We drop the plus 6x. Then x into x squared, we get a positive x. Then x multiplying the divisor, we get x squared minus 2x. Then if we subtract, here we get a 0. Here we get a 8x, positive 8x. Then we drop the positive 1 here as well. Then x into 8x, we get a positive 8. Then 8 multiplying the divisor x minus 2, we get 8x minus 16. Then subtracting here, we get a 0. Then here we get a positive 17. So the quotient Q is equal to x squared plus x plus 8, right? And the remainder R is 17, right? So this is what we get from number 4. And now let's look at number 5. So allow me to erase this part here. Okay, so now for number 5, first part, it says that show that x minus 4 is a factor of x to the power of 3 minus 3x squared minus 10x plus 24. So from the factor theorem, if x minus 4 is a factor, then f of 4 should be equal to 0. So we simply need to prove this condition, that f of 4 is equal to 0. So we're saying 4 to the power of 3, 4 to the power of 3 minus 3 times 4 squared, then minus 10 times 4, then plus 24. This will be equal to 64. Then 16 times 3 is 48, minus 48, minus 40 plus 24. Which if you subtract here, we get what? 1, get 16. 16 minus 16, that will give us a 0. So we've proven that x minus 4 is a factor. Then the second part says, hence factorize x to the power of 3 minus 3x squared minus 10x plus 24. So for the factorization, we can use long division, right? So we're dividing x minus 4 into x to the power of 3 minus 3x squared minus 10x plus 24. Like this. Then x into x to the power of 3, this give us x squared. Then x squared multiplying this divisor, we get x to the power of 3 minus 4x squared. And if we subtract here, we get a 0. Here we get x squared. Then if we drop the minus 10x, we say x into x squared, we get a positive x. Then x times x squared, x times minus 4x. Then if we subtract, get minus 6x. Then we drop the positive 24. X into minus 6x, we get a minus 6. Minus 6 times x, we get a minus 6x. Minus 6 times minus 4, we get a 24. So the remainder is 0, implying that the other quadratic factor that we have is x squared plus x minus 6, which when you factorize, you get x minus 3, get x plus 3, x minus 2, like this. So factorizing completely, the answer that we want will be x plus 3 times x minus 2 times x minus 4. Right, so this will be the completely factorized solution that we need. Now let's move on to look at number 6. So for number 6, first part, number 6 says the polynomial x to the power of 4 plus x to the power of 3 minus 22x squared minus 16x plus 96 is denoted by p of x. First part now says find the quotient when p of x is divided by x squared plus x minus 6. So for the first part, we're simply carrying out our long division. So 6a, we're saying x squared plus x minus 6. We're dividing this into x to the power of 4 plus x to the power of 3 minus 22x squared minus 16x plus 96, like this, right? So x squared into x to the power of 4, we get an x squared. Then x squared multiplies the divisor here to get x to the power of 4 plus x to the power of 3 minus 6x squared. Then if we subtract, here we get a 0, Here we get minus 16x squared. Then if we drop the minus 16x, we're saying x squared into minus 16x squared, get minus 16x. Then minus 16x multiplying the divisor, right? So in actual fact, here we drop everything, right? Because, so plus 96, so we're dropping this and we're dropping that, right? Such that minus 16x multiplying the divisor, we get a minus 16x squared. Sorry, what did I do here? This is supposed to be ugly. Let me make a slight correction here. So from here, right? From here, if we make the subtraction, yeah. So let me erase this part. Okay, so here if we subtract, we get minus 16x squared. Then x squared into minus 16x squared, this will give us 16, like that, right? Yep. Such that 16 multiplied, so here we would have dropped everything to say minus 16x then plus 96, such that we're saying minus 16 multiplying the divisor here, we get minus 16x squared plus 16x and plus, this is what? Plus 96, yep, plus 96 like that, right? And then, now if we are to subtract here, right, this will give us a 0, so this gives us a 0, 0, 0, right, like that. And then, now what's next? This is supposed to be a minus, such that minus 16x plus 16x will give us a 0. So the quotient that we want is x squared minus 16. That's the answer that we want. If we factorize it, it will be x minus 4, x plus 4. Right, and then 6b says, let's solve the equation p of x is equal to 0. So now if p of x is equal to 0, right, and after us knowing that if we factorize p of x, we get x minus 4, x plus 4, and then we get this as well, x squared plus x minus 6, which you can write as x minus 2, x plus 3, to give us a 0. Then we simply equate each of these to what? To 0. So we're saying either x minus 4 is equal to 0, which implies that x will be equal to 4, or either x plus 4 is equal to 0, which implies that x is equal to minus 4, or x minus 2 is equal to 0, which implies that x is equal to 2, or x plus 3 is equal to 0, which implies that x is equal to minus 3. So these are the solutions that we get for x. X is equal to 4, x is equal to minus 4, x is equal to 2, or x is equal to minus 3. Now let's move on to look at number 7. Okay, so now for number 7 says that the polynomial 6x to the power of 3 minus 24x squared plus ax plus b is denoted by p of x. When p of x is divided by x minus plus 1, the remainder is minus 21. So p of minus 1 is equal to minus 21. Then when p of x is divided by x minus 3, the remainder is 11. So p of 3 is equal to 11. Right, so question says find the values of a and b. So we shall use these two conditions. Firstly, p of minus 1 is equal to minus 21. We're saying 6 times minus 1, then minus 23 times minus 1 squared will give us a 1, and then plus a times minus 1 plus b to give us minus 21, such that minus 6 minus 23 minus a plus b is equal to minus 21, and minus a plus b, this will give us minus 29. If we take it this side, it becomes a plus. 29 minus 21, that will give us an 8. So this is equation 1. In equation 2, we shall use p of 3 is equal to 11. Thereby I say 6 times 3 cubed, that's 27, minus 23 times 3 squared, that's 9, plus a times 3, then plus b to give us 11. Right, so 6 times 27 minus 23 times 9, that will give us minus 45. So we're saying 3a, here we're saying 3a plus b is equal to 11. 11 plus 45 equals minus 45, then plus 45, that will give us 56. So this being equation 2, if you are to solve by the elimination method, these two simultaneous equations, we're saying this goes, right, the b's go, and then here we've got 4a is equal to 48, right, such that a will be equal to 12, and b will be equal to 8 plus a, which is 8 plus 12 to give us 20. So a would be 12 and b would be 20. These are the two solutions that we need. So a is equal to 12 and b is equal to 20. Now second part says let's factorize completely. So factorizing completely, what we can do here is that for part B, right, we are given what? Factorize completely, right? So this leaves a remainder, that leaves a remainder. So now if we were to substitute for A and B, we've got 6x to the power of 3 minus 23x squared, then plus 12 plus 12x plus 12x, then plus 20, right? This is our P of x. So now if you come up with the trial error, we see that already 1 is not a factor, minus 3 is not a factor, sorry, minus 1 is not a factor, and 3 is not a factor. So let's try 1, right? So say 6 minus 23 plus 12, then plus 20, right? So 1 is not a factor. If we try 2, let's say 6 times 8 minus 23 times 4, then plus 24, then plus 20, right? So 2 is a factor. So if f of 2 is given as 0, f of 2 is given as 0, this implies that x minus 2 is a factor, right? So if x minus 2 is a factor, then we can use long division, yeah? To say x minus 2 into 6x cubed minus 23x squared plus 12x plus 20, right? Then x here is saying 6x squared, then multiply this 6x cubed minus 12x squared, then this will be 0, this is minus 11x squared, then we drop the plus 12x, then we've got minus 11x, minus 11x squared plus 22x, and then there's minus 10x, then we drop the plus 20, and we've got minus 10, then we've got minus 10x plus 20, then we get 0 there. So for this one, we've got 6x squared minus 11x minus 10. And now can you further factorize this? Minus 60, we've got 12 and 5. We've got 10 and 6. We've got, what else? 5, 15. We've got 15 and 4. So we can definitely. So you can say 6x squared plus 4x minus 15x minus 10. Then factoring out 2x, we've got 3x plus 2 minus 5, 3x plus 2, then this will be 3x plus 2 times 2x minus 5. Right, such that if we were to completely factorize this, we'll get our answer as 3x plus 2 times 2x minus 5 times x minus 2. This will be the solution that we get after we factorize completely. Okay, so this was just looking at typical exam questions for modulus functions, the remainder theorem, the factor theorem, and division of polynomials. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.